So hopefully you're here for web performance. That's what I volunteered to speak about. So that's what we're going to talk about. Hi, my name is Kevin Lawver. I've been a professional web developer for about 25 years. Spent the first half of my career at AOL, built a really fast search engine in the early 2000s. And I worked on web standards like CSS and a little HTML, and did a lot of front-end performance work back in the early web when we had to worry about dial-up modems and really crappy browsers. And then after that, worked at a bunch of smaller startups as CTO. And then in the middle there, I ran a DevOps consultancy where I helped a bunch of other startups scale and deal with their own performance issues. And for the last year, I've been at Gusto, where I work on a bunch of different stuff, but one of them, oddly enough, is performance. So enough about me. I figured we should start with this because I talk to a lot of engineers and web developers who really don't understand how things get from the location bar to the screen and a rendered page. So figured we could start there, and then we'll all be on the same page and have the same terminology. Also, you get to see my amazing art skills. So I apologize for the image, but at least I drew it myself. I just not just go steal it from the internet, but we're going to walk through it all. So let's say you wanted to go to a website called tater.club. You can do this in your own browser. It is a thing that I did. It's very tiny for another presentation on, oddly enough, how the web works. So your browser doesn't actually know where that exists. So it talks to a DNS server, stands for domain name service, which is like a phone book for the internet, to see where on the internet tater.club exists. Tater.club happens to resolve to 66.33.212.47, which is an IP address. Once we have that answer, your web browser tries to open a connection, meaning a TCP port, to that IP address, :443, which is what we use for secure connections. If that doesn't work, it'll try port 80. That's for regular HTTP connections. And if that opens, and the server sends, cool, you're connected, then it's going to try and it's going to send a request over that connection for get /, which is the root. So if you remember, I don't know, some of us are old enough to remember the internet before the web. Like you were typing everything in. So the web worked in the old days by you actually typing get /. You would have to open it. You can do this on your own in your favorite programming language. You can open a connection to a domain 443, type get / and see what happens. Once we type get / assuming that exists, that path exists, then that server will return HTML, probably, which is not a programming language. It's a markup language. That's what the M stands for. It stands for Hypertext Markup Language, invented by our pal and yours, Tim Berners-Lee, 20-something years ago, almost 30 years ago. So what happens, your browser gets that back and parses it, and then turns that into a document object model, which is the browser's sort of mental version of what the HTML said. So if you send bad HTML, it'll have a bad mental model, and it probably won't look like what you want it to look. And then once it parses the HTML and gets the DOM, it goes and looks for what are all the external resources that I need to get to build this page. So it won't do any rendering until it gets any CSS or scripts, JavaScripts that you've put in the HTML, unless you tell it you can defer them. And then it has to parse those and compile. It actually compiles them and then apply them, the results of that compilation, to the DOM. Now we get to the first render. And then it says, okay, what else do we got? Do we have images? Do we have movies? Do we have all kinds of other stuff on this page that, like, the logo. Your CSS could call other images, probably does for background images and stuff like that. And then we get the onload event, which means the browser's like, okay, I've got everything. The page has been rendered. Things are still. We're done for now. And then your JavaScript can go do other stuff. Okay, that was a lot. I admit that it was a lot. You had a very terrible illustration to look at. Don't try to remember it all. I just wanted to make clear just how much happens when you try to go to tater.club. The payoff for that, not worth all of the effort that your browser goes through to make it happen. But the reason I wanted to go through that, other than everyone should know it, is every part of that process can impact performance. So we're going to go in order through all of those things and talk about how you can, at a basic level, optimize for them. Ready state change is a React only thing as far as I know. But it's also an event. There are lots of events. So DNS, again, stands for Domain Name Service, invented by a guy named Postel. You look up Postel's law when you have a chance. It's pretty great. So your DNS for your website, say tater.club, hosted somewhere. And then when you configure that, you tell it, here's how long you can cache this domain name in your system. So that's called time to live. If it's short, then every other DNS server in the world has to go back to your domain name server and ask for an update. You can have them as short as 1 minute. You can have them as long as a day. You can have them longer than that. Day is probably enough. So if you're deployed, your site is up and running, you want to set that TTL to as long as possible. So you don't have to make a lot of hops to get an answer back. You want it to be as close to the end user as possible. So there you go. DNS taken care of. You're all DNS masters now. So SSL, you'll notice tater.club works with HTTPS. SSL has a huge impact on performance. So SSL stands for Secure Socket Layer. That's the little lock in your browser. If you have SSL on your site and you have that little lock, the browser can make more concurrent requests, which means all of those associated things get done faster. You can also use things like web workers to send data to the browser later on. We're not going to talk about web workers. That's kind of a little beyond where we're going today, but they are a great way to preload data for later use. Like you could do everything. You could preload all the data that a user really cares about using just web workers and notifications and local storage. It would be awesome. SSL is also a prerequisite for using HTTP 2 or trying out HTTP 3. Don't try to set either of those up yourself. If you're self-hosting, it's a pain. Use Cloudflare or Fastly or some other DNS provider. We'll talk about them later. And then with Let's Encrypt, you can get SSL for free. And you can set up a cron job on your server to renew your cert every 30 days. And then a lot of hosting providers will handle that all for you. So there's really no excuse not to use SSL now. If you use Heroku or Render or Netlify or any of those, they all will do SSL certs for you. They used to be really expensive and a huge pain. I am really glad that the web has figured out that they should not be and should be free. So this is a good place to talk about CDNs. CDN stands for Content Delivery Network. It's like your site. Okay, it depends on how you're hosting it, but let's say you have a machine on your desk and you live in, say, Savannah, Georgia. Everybody who wants to go to your website has to send a request to Savannah, Georgia, and then has to get an answer back from Savannah, Georgia. A CDN is like, yeah, we can take care of that for you. So you can make a request and the CDN will handle it much closer to the end user. Say if you're in New York, we'll go, hey, CDN, do you have this? Cool, serve it from New York instead of going all the way down 95 to Savannah. This again used to be a really, really expensive thing. When I was at AOL, we used Akamai, and they were insanely expensive, but they are now insanely easy and also free in some cases. If you host with Netlify or Render or other similar static site platforms, they're not just hosting your site, they are also a CDN. If you use Cloudflare or Fastly for your site's DNS, they also do some really fancy CDN things, which, speaking of, let's talk about them because they're amazing. Cloudflare started as a DNS provider, so you could just like put all your host names there and say, hey, they point here on the internet. They now do all kinds of stuff. I used to be really against this idea, but the more features that they've added, it's really hard to come up with reasons why you wouldn't put Fastly or Cloudflare in front of your site. They don't do host. I think Cloudflare does do static page hosting now, but like, say you, again, your server sits on your desk in Savannah, Georgia. You can put Cloudflare in front of it, and it can handle SSL for you. It can handle HTTP2 for you, HTTP3, and it can do all this other stuff. This is not an ad for Cloudflare, but I've used it the most. But they do edge servers, custom caching rules, and some really advanced image compression stuff, so you don't have to worry about it. And all of these are useful things as far as performance. Speaking of compression, let's talk about that. So HTML, CSS, and JavaScript are all, they're just plain text, meaning they can be compressed a lot between your web server and your end user. If you're self-hosting, your whatever web server software you're using probably supports enabling, Apache used to call it deflate. It's basically gzip. So it just compresses everything that's text that goes out from it. You should turn it on if you're not already supporting something else or not already doing it somewhere else. But if you're using something like Nginx in front or DNS as CDN, make sure that it's turned on there. It makes a huge difference. So images, other than SVGs, we'll talk about in a second, are pixel-based. So they're binary. They don't really benefit from gzip compression at all. It's actually, there's been studies done. These were a long time ago, so it might be different now that CPUs are faster, but gzipping binary actually made performance worse because now not only are you sending binary, you have to decompress binary, so that kind of sucks. But you should optimize them before they're on the web. So if you use full color photos, you should play with export settings in your photo editor. You can usually get away with JPEG compression somewhere between 60 and 80, which will make those images a whole lot smaller. We're talking from like multiple megabytes down to less than a megabyte. And if you're using vector images, SVGs are infinitely scalable, and they're also plain text. So they can be compressed by the web server, which is amazing. You can also use CSS on them, which I think is fantastic. So you can do like keyframes and other wicked things. So you don't even have to use animated GIFs anymore, which is super cool. Like my favorite saying is that as hard as it is, it's never been easier. And we're seeing why. Like we used to have to use animated GIFs. We used to have to like pray that they downloaded correctly. And that animation had better be worth it because someone was actually paying real dollars to fetch it. So here we go. Performance fundamental. The less you send over the wire, the better. Most web performance is still about the sheer amount of stuff that we send to the end user from our web server or whatever is in the middle of your web server. So the less you send, the better. So compression is great. Sending less stuff is great. Using caching, so setting reasonable cache times for all of your assets means your users don't have to request them again when they come back. So most build pipelines now, Webpack, whatever else there is now, if you use Rails and our old school asset pipeline, they'll all create digests. So like when you change it, it'll just create a new version of it. So you can have expires times of a year or more, and no one will ever like get a bad experience, because the next time you deploy, it'll get the URL will change and they'll get the new file and everything will be fine. So HTML, unless you're doing everything inline, like you have all your SVGs and JavaScripts and CSS in your HTML, which really nobody does anymore, but I have seen like people do it, especially SVGs. I don't know why people embed SVGs, but they do. Your HTML will never be like your main performance problem. In general, though, keep it semantic, keep it descriptive, and use it over JavaScript where possible. Browsers are really, really good at rendering HTML at this point, so we should totally let them. I really love the current state of the web where every HTML document that we serve is empty, and then we shove a bunch of stuff with React into it. This is my old man shakes fist at sky moment. CSS, again, it's rarely your biggest performance problem. It's only when we start haphazardly including everyone else in the world CSS that it becomes a problem. Definitely split it up. So like if you think about the modern web app that you would build, you have sort of the front pre-signed in marketing stuff, and then the signed in, you're actually using it stuff. And if you can keep those separate, your life will be a whole lot better. Serve just the marketing stuff for the people who aren't logged in. And when after they're logged in, they go to logged in view, serve them only the real stuff, because they don't need both. It makes it just easier to maintain. I like it just overall, it's great. And then remember, if you're serving over SSL, especially if you're doing HTTP 2 or 3, it can be faster to serve more smaller files than one big one. So I know modern build tools really like creating one big one. It's actually kind of a pain to configure them to create smaller ones. But think about it, like there's a trade-off. Like at some point, you're sending too many, and you run out of open connections that you can use. But it really, if you can do it by major segment or major feature, then I think your users will be happier and you can get around a lot faster. Oh, this is the one. This is the thing. We're all building single page apps now, even me, the last holdout. And that's lovely, but they come with a lot of JavaScript. All these frameworks, we're just haphazardly pulling in packages from NPM. That JavaScript not only takes time to download, but the browser has to compile it and run it, which is on the phone or an older computer. It's a thing. It impacts performance. So some tips for improving perceived performance with JavaScript: split your scripts up, make sure the most important stuff is loaded synchronously, and then everything else can be added to the page using the async attribute, so it doesn't block the initial render. You want to get from I requested the page to the first render as quickly as possible. We'll talk about perceived performance in a little bit. We talked about the separate experience, but like my favorite trick is there's a thing called a prefetch link. So it's link rel equals prefetch and then href equals whatever the URL is. Like if you have a separate experience for people who are logged in, you could put all the assets for that experience as a prefetch link on the marketing page. So they're already in the cache by the time they log in, which will make it seem super quick. You will be a hero to everyone. Other things to think about: do I really need the whole package? Could I write it myself in fewer lines of code? And then import only what you need. Like, don't import the whole package if you're doing ES6 things. If you really only need one function, you can usually import just the function. And then this might seem heretical to the single page app world, but try to do as much as you can with foundational web technology. Maybe it could be a plain HTML and CSS page. Does it need to be a single page app? Do you need JavaScript for this? Like, my favorite is forms and the thousands of lines of JavaScript that we write to do things that forms do by their nature, by the spec, by how they're implemented in browsers. So like, my favorite is the button on click, submit the form. If you just made that a submit button, it would do that for you, and you can capture the submit event and do your thing. You don't need Formic and everything else. Sorry, old man shaking fist at sky moment again. So another performance fundamental: it's easier to not add something than to remove it later. And this goes to the package thing. Like, if you can avoid importing a package, you can save yourself a lot of pain later on trying to figure out, am I even still using this? What part am I using? Those questions get more difficult to answer the more packages you're pulling in. Here we go. Perceived performance. Your loading animation is cool, but it makes your app feel slower. Loading placeholders where possible and individual spinners on things so you can fill them in as they load is probably a better approach. Like, if you can do your navigation, whether it's top, left, whatever, in plain HTML, and then inject your single page app inside of that, your site will feel a lot faster, even though it takes just as long to become usable. This is kind of why I prefer HTML with JavaScript augmentation over SPAs, because like almost every SPA has a loading graphic. It's like, why are you making me wait when you could tell me give me at least a preview of what I'm going to get. Placeholders are kind of a pain to implement sometimes because they can change height, once the actual content gets filled in, which is super fun as well. But definitely worth trying it when you're starting something new, because it's very difficult to add later. So use your expectations. Know what you're building and kind of what your users will demand from it. So there's a ton of science around this about how long users will wait for things, and when they start to get annoyed so much that it actually impacts revenue. Because really, like, if people are paying us to build things, they want to make money from them. So we should help do that. So shopping sites, utilities like banking, calendars, email, have the lowest amount of patience. People want it now. They want it right away. They are not willing to wait more than a couple hundred seconds, or sorry, couple hundred milliseconds. Couple hundred seconds would be really funny, before they start like losing their attention span or getting angry and deciding to go somewhere else. Entertainment, so games, web toys, streaming sites, like, people have the most patience because it's idle time. They're trying to fill that idle time. And then literally anything else you could build is somewhere in the middle. So like, do some user testing, ask people in the industry, like, what's your sort of benchmark? Actually ask your product managers if you're an engineer, what's your performance benchmark? Set them and measure them. And then backend, like, we've spent 26 minutes talking about front-end things. We haven't talked about back-end things. So this is a huge topic that's really dependent on your tech stack, what your app does and how it grows over time. So I'm really only going to cover some basics so you can go interrogate your tech stack and see if maybe you have these problems. So level set, everyone has made these mistakes. Everyone makes them, has made them forever and ever. They continue to make them to today. So avoid unbounded queries. Never assume all your data will fit in a single request. I would paginate by default. And if you do that, you'll never fall into the trap of things mysteriously not working because you're trying to load everything and you just happen to go over the amount that would fit in a request. And so the earlier you plan for pagination, the better, because you can get your designer involved. You could do infinite scrolling, which is just pagination without the pager. It has a huge implication on design, so get people involved in that. And then monitor everything. Like it could be as simple as up-down notifications using Pingdom or whatever, but you should know what your performance looks like on a day-to-day basis so you can know when it's changing. Like, is this request slower this week than it was last week? It's also great to know about hotspots in your code where you are starting to have performance problems before your database melts down or your users start complaining. Oh, that's a great, I'll get to that one in just a second. So design and test with lots of data. Like the more that work you can do up front to make sure your designs can handle a user with 1,000 items in their shopping cart, the less time you'll end up scrambling in the middle of the night trying to figure out why things are broken. So design with more than one page of data in mind, and then think through the worst case scenarios. Think through your worst case scenarios for your app before your users do. And all of this might sound scary. I've gone through a lot of worst case scenarios here. Most apps never, ever, ever have to scale or worry about performance. So get the thing working first and hope that one day you'll have to worry about performance. There's a spectrum of knowing how much planning ahead to do. That really only comes from experience. And if you're just starting out, like I said, just get it to work. Worry about everything else later. Getting it to work is the most important step. So there we go. It's question time. I think that means we have, we have time. That's cool. We have 15 minutes for questions. The first one is from Safa. Which is a better approach to improve performance? Is it prefetch or lazy loading? Both. Prefetch is for things that you don't need on the current page. Lazy loading is for things that you will eventually need on the current page. So if you do, this makes product people really angry, but analytics, I don't think is something that users really need. So like, I'm more than happy to async analytics stuff, so it can happen later. Oh, that's good. So yeah, let me know if that didn't make sense. But really, prefetch is for things that they will get to when they're logged in, or things that they might get to if they click in. Lazy loading is for things that don't matter for the initial render, but will actually need to be there for some other secondary feature to work. So the next one is from Zhao. First, congrats on the presentation. I'm enjoying it. What solutions would you think of for a front-end page that queries a huge database, 1 billion records, maybe pagination? Cache wouldn't work because keywords always change. Kind regards. So definitely pagination. When you get to that size, you're going to need to, so here, said I wasn't going to talk about backend things, but I totally am. As your database gets to a certain size, you have to limit the ways that you query it so you can keep your indexes in memory. So like when your database is a tiny baby database, all of your data fits in the memory on the database server for the most part. So every query is super fast. As it grows, you need to add indexes on top of that data. So those can stay in memory, even if the underlying data is not. Eventually, you will, even your indexes won't, like all your indexes won't fit in memory. So you need to constrain the kinds of queries that you do to keep those hot indexes in memory. 1 billion records really isn't huge. You should be able to add indexes on that. But yes, you definitely should add pagination. You should look at your queries, make sure they're covered by indexes. That's assuming a classic relational database like Postgres or whatever. So I think I covered that one. And then Ethan asks, any tips for reducing app bundle size? Next.js recommends app bundle size be below 130K. That just doesn't seem attainable anymore. Like if you're building a single page app that actually does a lot of stuff, I don't see how you're going to be less than 130K. What I would start with is see if you can split that bundle up into things that you know you need, frameworks like Next.js or Vue or React, and then actual pieces of functionality. So could you have a bundle for marketing, onboarding, reporting, actual usage? So like start splitting bundles up into separate feature sets, and then you can load them you could load them all like in script tags, and just it'll be faster because you're splitting it up into multiple requests instead of one single long running request. My other favorite is just start randomly removing packages and see what breaks. So like package.json, just start deleting things. See what breaks. I think there are some decent JavaScript package, bundle analyzers that will tell you that you're importing all of this, but you're not actually using it. I'm not an expert on those, but I would look into that. And then Amin asked, just a second. What's your recommendation, inline CSS or external? And what about packages like style components? I always external CSS because it's cacheable. So if you use the same component on two separate pages, then you don't have to load the CSS more than once. It's still in the cache, always external. It also then means you can optimize the CSS itself without worrying about, changing it inline stuff. I just don't like inline CSS. It feels like a step backwards and not a step forwards. Style components, I think, has the same problems it expects inline CSS, and I really think that's a mistake. If you're already using them, I don't think you can easily move back to external CSS, but see if it's an option. Okay, Zhao's back. Just making a link with what you said about lazy loading right now. Would lazy loading work in this scenario about querying 1 billion records? No. I mean, it might, but like if you said the data changes often enough that you can't cache it, lazy loading actual like search results won't work because it's like pre-filling the cache. And if the data is too hot to cache, then you don't really want to lazy load it. I need to know a lot more about the use case, because like this is one of those things that like you're gonna need to experiment with, like, okay, can we paginate it? Can we put, like, if it's just sitting in a relational database, could you put Elasticsearch in front of it? So you're using a real text search engine, which will be a lot faster. There's just too many options to narrow it down without knowing the use case. Great, glad I could help. Okay, other questions? What else do you want to know? Or was there a part that was confusing? that I could have done better than. Or do you love inline CSS and you want to start a nerd fight about it? I'm okay with that too. Thanks, Connie. Oh, I've been a Rails user for 15 years, longer than that now, 18 years. So I still love Rails. I still think Rails is the fastest way to go from I have an idea to users telling me if that's a good idea or not. It's also super flexible. On the front end, I think I would still start with attempting plain HTML and CSS and then adding JavaScript where needed. But I kind of understand that users kind of have this expectation about the web now that it is more appy than pagey. But I would like interrogate your design and go, is what I'm building web, appy or pagey? If it's pages, then use regular web pages. If it's appy, sure, have no guilt about building a single page app. Okay, this is Ethan. Love this question. Love it, love it, love it. Any guesses? Ethan asked, any guesses on where the web is headed and performance challenges with that? Web3, VR, etc. I think crypto is a Ponzi scheme, so I think Web3 is a Ponzi scheme by association. I don't really think Web3 is the future. I think there are a lot of people who want to make money off of it by pretending that it's the future. I think VR on the web is really, really interesting. Like, I think there are some crazy fun design possibilities with web VR. I think 3D rendering in the browser could open up. I think our tooling needs to get better. So like we need Web 3D to be as easy to use as Unreal Engine or Unity. But like you could people ship games on the web now, but being able to ship a real competitive first-person shooter with 3D graphics just for the web would be unbelievable. I think that's coming. I think JavaScript is just going to keep getting better and browsers are going to keep getting faster. I think web components they're kind of already here. They're just not, it's like, what's the old phrase? The future is here, it's just not evenly distributed. I think web components to some degree for appy type things are the future. They're just not evenly distributed. And then Tim asked, do you have specific profiling tools strategy like, yes, please use, here, I'll do it here. Please use the developer console. So in Chrome, it's View, Developer Tools. There is the network waterfall is super useful. So let's look at it. You go to the network tab, and you hit reload. Like it will show you when the page is done, like how long it actually took to load, which is great. So like it showed that it took it. We're playing along with as it loaded. Don't want to do that. Stop that. But you can see like nope, I didn't want to do that either. So here, we'll reload again. Hopefully I won't scroll. But you can see like all of the assets that are loading whether they failed or not. I'm not sure why they would fail. So, oh, I've disabled the cache. No, I didn't. Why are these all 200s? That's crazy. But like you can see that it actually took 8 seconds to load everything because everything happened. Here, I'll try to make this bigger. Everything happened in one line. Like if you go to a lot of pages, you'll see like a waterfall. Like if we go to, like you'll see things that happen concurrently. So like there's a long running request, we get all the stuff you kind of need, and then there's like all of these assets happen at the same time. So that's really what I would use is get comfortable with the network tab and then performance. Like you can record page loads and then it will kind of tell you what the problems are, which is great. So I'm going to stop sharing. Yeah, you can also throttle in that tab. So that's great. Okay, so Jazz, what do you think about Django or Node.js? Do you prefer any of them? I think Django and Rails, they kind of came about at the same time. So they're actually very comparable. Node.js is in everything. I still prefer Rails over any of them. I used to be a zealot. Like I used to care about what frameworks people use. I don't anymore. You should use the one that helps you get things done because the performance problems will be pretty much the same no matter what stack you end up using. They all come down to trying to shove too many things over the network or trying to query too much data. So it becomes like a database problem, not what framework you use in between. Any last minute questions? Because we are almost at time. Yeah, you should always go back to favoring productivity, whatever helps you move faster. Um, when do you actually want to get things done? Like there are times when you want to experiment. Please, you should experiment. It's how we like learn new stuff. Like if no one had looked at Rails after it came out, then we wouldn't have Django or Express or Phoenix or Laravel or Cake or any of the other things that were inspired Rails, any of the other stuff that was inspired by Rails. So definitely play with stuff. Ask people questions. If you know a Rails fan, ask them why they love it. They'll be happy to tell you. Cool. Thank you all for coming. This was super fun to prepare. I think we are now out of time. So have a great day, everybody.